You're about to see the most overpowered outboards ever built, engines so insane they redefined what's possible on water. We're talking over 600 horsepower from single motors, quad setups delivering 2,400 combined horses, and price tags rivaling luxury cars. But here's the real twist. The most powerful production outboard ever made forced every major manufacturer to completely redesign their flagship engines overnight. Then the company behind it vanished completely. Today we're exposing 12 of the most extreme outboard power plants ever bolted to transoms, including industry secrets manufacturers definitely don't want you knowing. The Mercury V12 Verado 600 didn't just raise the bar when it launched in 2021, it completely obliterated it. This beast is the first production V12 outboard engine ever created, and Mercury spent over 5 years developing it from scratch. Here's what makes this engine absolutely bonkers. It's a naturally aspirated 12-cylinder power plant, displacing 7.6 liters. Generating 600 horsepower with exceptional torque throughout the RPM range. The quad-cam configuration with 4 valves per cylinder provides tremendous low-end grunt. What really sets the V12 apart is the adaptive speed control system, monitoring boat load and sea conditions 100 times per second, automatically adjusting engine parameters to maintain your desired speed. The cooling system uses a closed-loop design with a 3.2-gallon coolant reservoir, running on coolant rather than raw seawater, dramatically reducing corrosion. These motors retail around $77,000 each. Quad installations can push your engine package north of $300,000 before rigging and controls. Early production runs experienced teething issues with electronic throttle bodies, requiring software updates under warranty. But when these engines run right, they're transformative. Boats equipped with quad V12s hit 80+ miles per hour, while carrying 1,000 gallons of fuel and 8 people. The acceleration is violent, the top-end speed impressive, and the whole shot rivals dedicated performance boats. This is $300,000 worth of outboards delivering capabilities that seemed impossible just a decade ago. Coming up, we're revealing why one manufacturer's $80,000 outboard completely failed in the market, despite being more powerful than anything else available. You won't want to miss that story. Here's the story that explains why every major outboard manufacturer now offers 400+ horsepower engines. Seven Marine built an outboard so outrageous that it forced the entire industry to respond. The Seven Marine 627 wasn't just powerful, it completely reimagined what an outboard motor could be. Seven Marine's approach was revolutionary. Rather than developing a purpose-built marine engine, they took a 6.2-liter LS3 V8 from General Motors and marinized it for outboard use. This single overhead cam V8 produced 627 horsepower at 6,000 RPM and 627 pound-feet of torque at 3,850 RPM. Those numbers were so far beyond anything else available that many industry insiders initially dismissed the entire concept as a publicity stunt. But Seven Marine wasn't joking. The company invested heavily in engineering a bulletproof drivetrain to handle the massive power output, designing a custom gear case using aerospace-grade materials. These motors weighed approximately 1,000 pounds. The distinctive black anodized finish and muscular styling made them instantly recognizable. Seven Marine understood that buyers paying close to $90,000 for a single outboard wanted something that looked as exceptional as it performed. Performance was absolutely brutal. Center consoles equipped with twin 627s routinely hit speeds exceeding 80 miles per hour while carrying full fuel and passengers. The acceleration was violent, the mid-range passing power overwhelming, and the top-end rush addictive. The story behind Seven Marine's end reveals industry realities. Volvo Penta acquired Seven Marine in 2017, initially planning to continue production. However, production ended in early 2021 when Volvo Penta discontinued the brand entirely. The Mercury Racing 450R represents genuine racing technology in a package you can actually buy. This isn't a detuned race motor. It's the real deal, developed directly from Mercury's offshore racing program. Under the cowling sits a supercharged 4.6-litre V8, generating 450 horsepower at 6,000 RPM. The twin-screw supercharger force feeds compressed air into the combustion chambers, producing massive torque across the entire RPM range, with peak torque arriving at just 3,500 RPM. Mercury Racing uses strengthened aluminium castings with enhanced ribbing, forged pistons, shot-peened connecting rods, and a fully counterweighted crankshaft balanced to tolerances measured in thousandths of an inch. This engine survives sustained wide-open throttle operation in offshore conditions. A single 450R pushes a 25-foot center console into the mid-60 mph range, while twin installations on 35-footers regularly exceed 75 mph. The Sportmaster gear case features a 2.38:1 gear ratio optimized for high-speed applications. Fuel consumption reality. At wide-open throttle, a single 450R burns approximately 35 to 40 gallons per hour. The 450R retails around $58,000. Maintenance requirements exceed standard outboards. Oil changes every 50 hours, gear case service every 100 hours, supercharger servicing every 200 hours. The reality nobody talks about. Some marine mechanics argue the 450R is over-engineered for most applications. The supercharger complexity creates more potential failure points, and replacement parts carry premium pricing, but for those demanding maximum performance, nothing else delivers quite like the 450R. Here's a controversial pick. The Evinrude E-Tech G2 300 HP represents what could have been the future of outboards, before BRP pulled the plug on the entire Evinrude brand in 2020. This engine proved that two-stroke technology wasn't dead. It just needed serious reimagining with modern direct injection and sophisticated engine management. The E-Tech G2 used a 3.4-litre V6 two-stroke power plant with direct fuel injection, producing 300 horsepower at 5,800 RPM. What made this engine special was how it combined two-stroke simplicity with four-stroke refinement. The direct injection system eliminated the smoke, smell, and excessive fuel consumption that killed traditional two-strokes, while maintaining lighter weight and simpler mechanical design. At just 527 pounds, the E-Tech G2 300 was dramatically lighter than competing four-stroke 300 horsepower outboards. This weight advantage translated to better performance on smaller boats and improved fuel efficiency through reduced mass. The engine required no valve adjustments, no timing belts to replace, and significantly fewer internal components than four-strokes. Evinrude's sophisticated Rave exhaust valve system constantly optimized exhaust timing based on RPM and load, maximizing power and efficiency across the operating range. The engine also featured auto-winterization, where the system automatically fogged itself when shut down in cold weather. The controversial end came in 2020 when BRP discontinued Evinrude entirely. Parts support continues through BRP's network, but the brand's death left E-Tech G2 owners with orphaned engines and uncertain long-term prospects. Before superchargers dominated Mercury Racing's lineup, the 300R proved you could build a serious performance outboard without forced induction. This naturally aspirated beast uses the same 4.6-litre V8 architecture as the 450R and 400R, but it achieves its 300 horsepower through aggressive tuning and racing-derived technology. The 300R cranks out 300 horsepower at 6,000 RPM from pure displacement and sophisticated engineering. The engine features Mercury Racing's quad-cam 4-valve design with double overhead camshafts, high-performance intake cam profiles, and race-spec Inconel exhaust valves. The result is linear power delivery that many enthusiasts prefer over supercharged engines, with instantaneous throttle response. At 668 pounds, the 300R is lighter than its supercharged siblings, providing exceptional power-to-weight ratios on smaller performance boats. Single installations work brilliantly on 25 to 30-foot center consoles, while twins deliver serious performance without the complexity of superchargers. The naturally aspirated design means simpler maintenance schedules, fewer potential failure points, and lower operating costs. The 300R retails around $45,000, positioning it between standard outboards and supercharged Mercury racing models. Fuel consumption averages 20 to 25 gallons per hour at cruise, noticeably better than forced induction alternatives. What separates the 300R from its supercharged brothers is the driving experience. The naturally aspirated power band feels more organic, building power progressively rather than hitting with sudden supercharged thrust. For purists who value throttle response and linear delivery over peak numbers, the 300R delivers genuine racing credibility without forced induction complexity. If the 450R represents maximum aggression, the Mercury Racing 400R is the thinking person's performance outboard. This engine offers about 90% of the 450R's capacity at roughly 80% of the cost, making it arguably the best value in Mercury Racing's lineup. The 400R shares the same basic 4.6-liter V8 architecture as the 450R, but runs a lower boost level from its twin-screw supercharger. This detuning produces 400 horsepower at 5,800 RPM, while actually improving fuel efficiency and reducing mechanical stress. The result is serious performance with better longevity and lower operating costs. Mercury engineered the 400R with versatility as the primary goal. The engine performs exceptionally well across a broader range of applications than the 450R, from 23-foot bay boats to 40-foot center consoles. Single installations provide spirited performance, while twins offer genuine high-performance capability without extreme costs and fuel consumption. The digital throttle and shift system eliminates mechanical cables, providing incredibly precise throttle control and enabling features like joystick piloting for close-quarters maneuvering. The system also allows custom start, where you preset your preferred idle RPM. Pricing for the 400R sits around $53,000, making it about $5,000 less than the 450R. Fuel consumption at cruise is approximately 25 to 30 gallons per hour per engine, noticeably better than the 450R. Understanding what you're actually getting involves honest assessment. The 400R makes 50 fewer horsepower than the 450R, translating to roughly 3 to 5 miles per hour lower top speed in most installations. You need to honestly assess whether those extra horses justify the additional cost and fuel consumption. Before Mercury developed the current V8 supercharged 400R, they produced 2 previous generations using completely different engine configurations. Under this evolution tells the story of how outboard technology has progressed over 2 decades. The original Mercury Racing 400R debuted in the early 2000s, using an inline 6-cylinder configuration. This engine was essentially a Marinized 2-stroke powerhead optimized for racing applications. The i6 produced 400 horsepower through aggressive porting, high compression ratios, and tuned expansion chambers. These motors were temperamental, required constant maintenance, and burned fuel like a house fire, but they won races and established Mercury Racing's reputation. The second generation arrived around 2008, featuring a V10 configuration that remains legendary among performance boating enthusiasts. This 4.6-liter V10 with electronic fuel injection produced 400 horsepower at 6,200 RPM. The V10 used a unique cylinder bank angle and sophisticated balance shaft system to eliminate vibration. Mercury Racing hand-assembled each powerhead and dyno-tested every unit before shipment. The V10 delivered power differently than the peaky i6 2-stroke, producing massive torque across a wide RPM range. The cylinder head design proved problematic though, with some engines experiencing valve train issues after extended high RPM operation. Production of the V10 ceased around 2015, with Mercury transitioning to the current V8 supercharged platform. Many performance boating enthusiasts still prefer the V10 over the current V8, valuing its naturally aspirated throttle response and exotic engine note. Before 7 Marine built the legendary 627, they started with two smaller models, the 557 and the 527. These engines used the same basic LS architecture, but with different displacement and boost levels, creating a range of options for different applications. The 557 was the original 7 Marine engine, launching around 2014. This motor used a 5.7-liter LS Series V8 with a supercharger producing 557 horsepower. The engine shared many components with the later 627, including the custom gear case, mounting system, and electronic controls. Single installations pushed mid-sized center consoles into the 60 mph range, and twins took larger boats well past 70. The 527 arrived later as a more affordable option, using the same 5.7-liter displacement but running lower boost pressure to produce 527 horsepower. This detuning improved fuel economy slightly and reduced mechanical stress, though differences were marginal in real-world use. The LS architecture is proven and robust, with decades of development behind it. 7 Marine's engineers understood the platform intimately and made appropriate changes for marine duty. Most failures occurred not in the engine itself, but in peripheral systems like electrical components or transom mounting hardware. Pricing for the 557 sat around $80,000, while the 527 came in slightly cheaper. The downside was parts availability and service network. 7 Marine never established the dealer infrastructure that Mercury, Yamaha, or Suzuki enjoy. Finding qualified technicians was challenging outside major boating markets. While Mercury and 7 Marine battled for bragging rights in the performance outboard segment, Yamaha took a different approach. The XTO Offshore 450 wasn't designed to win races or set speed records. It was engineered specifically for serious offshore fishing and the unique demands that application creates. Yamaha designed the XTO around a 5.6-liter V8 engine producing 450 horsepower at 5,500 RPM. That massive displacement generates enormous torque, with peak output of 575 pound-feet arriving at just 3,500 RPM. This torque characteristic is perfect for heavy offshore boats that need to punch through rough seas while fully loaded. The XTO stands apart from competitors through its gear case design. Yamaha engineered the largest gear case in the outboard industry, using massive gears and bearings designed to handle tremendous shock loads. The lower unit uses a 2.11:1 ratio that balances whole shot performance with top-end capability. Yamaha built this engine with commercial fishing operations in mind, which means reliability and durability took priority over maximum performance. The cooling system uses fresh water for the engine block with heat exchangers, dramatically reducing internal corrosion. Yamaha claims the XTO can run continuously at wide open throttle for extended periods without damage. Pricing for the XTO sits around $50,000, making it competitive with Mercury Racing's offerings while providing different performance characteristics. The XTO is heavy though, weighing approximately 1,115 pounds, which limits applications on smaller boats. In 2022, Yamaha introduced the XTO Offshore 425, expanding their extreme offshore lineup with a slightly detuned version of the XTO platform. This engine uses the same basic 5.6-liter V8 architecture, but produces 425 horsepower instead of 450, creating an interesting alternative for buyers who want XTO capability at a reduced price point. The power reduction comes from different camshaft profiles and adjusted engine mapping rather than fundamental hardware changes. The result is an engine that produces 425 horsepower at 5,300 RPM, while generating very similar torque characteristics to the 450 model. In real-world applications, the performance difference is minimal, with most users unable to detect the 25 horsepower gap during normal operation. Yamaha's strategy with the 425 is transparent, offer the same legendary XTO reliability and features at a lower entry price. The 425 uses the identical gear case, mounting system, and electronic controls as the 450, meaning parts commonality is excellent and servicing procedures are identical. Fuel consumption between the 425 and 450 is nearly identical in most conditions. which raises interesting questions about which engine makes more sense financially. The 425 retails for approximately $3,000 less than the 450, but you're not gaining any efficiency advantage. The XTO 425 makes particular sense in twin or triple installations on boats in the 35 to 45 foot range. Triple 425s provide 1,275 combined horsepower, more than adequate for the vast majority of offshore applications, while saving money versus triple 450s. While the big names battle for high horsepower supremacy, Suzuki quietly built one of the most impressive outboards in the entire market. The DF350A doesn't generate headlines like the V12 Verado or 7 Marine engines, but it represents exceptional engineering and offers compelling advantages for specific applications. The DF350A uses a 4.4-liter V6 engine with dual overhead cams and 4 valves per cylinder. This inline V6 configuration produces 350 horsepower at 5,500 RPM, producing strong performance without the complexity or cost of V8 or V12 designs. Suzuki engineered this power plant with an offset drive system that positions the crankshaft forward of the drive shaft, improving weight distribution. The DF350A's standout quality is how refined it is. This engine runs remarkably smooth, with vibration levels significantly lower than competing outboards. Suzuki uses a sophisticated balance shaft system and precision machined components to eliminate harshness. At idle, you can barely feel the engine running. At cruise, it's whisper quiet compared to larger displacement motors. The fuel efficiency of the DF350A is outstanding for its power class. Suzuki's lean burn control system optimizes the air-fuel mixture across the RPM range, improving economy by as much as 20% compared to conventional fuel mapping. Real-world testing shows the DF350A averaging 22 to 25 gallons per hour at cruise speeds. Pricing for the DF350A sits around $38,000, making it substantially less expensive than Mercury, Yamaha, or Honda equivalents. This price advantage extends across the ownership experience, with favorable parts costs and service intervals. Honda entered the high-power outboard market relatively late, introducing the BF350 in 2017. This engine represents Honda's methodical, engineering-focused approach to outboard design, emphasizing reliability and efficiency over raw performance metrics. The BF350 uses a 3.5-liter V6 engine with Honda's signature VTEC variable valve timing system. This technology adjusts valve lift and duration based on RPM and load, optimizing performance across the entire operating range. At 350 horsepower and 5,800 RPM, the BF350 matches Suzuki's output while using smaller displacement, demonstrating Honda's focus on efficiency and power density. Honda engineered the BF350 with their famous automotive reliability standards. The engine uses a timing belt rather than a chain, reducing noise and mechanical complexity. Honda's sophisticated engine management system monitors numerous parameters constantly, adjusting operation to prevent damage and maximize longevity. The BF350 distinguishes itself with its integrated hydraulic steering system. Most outboards require separate hydraulic steering components, but Honda builds the steering cylinder directly into the motor. This integration reduces installation complexity, eliminates potential leak points, and provides incredibly precise steering feel. The physical design emphasizes compactness and lightweight. At approximately 770 pounds, the BF350 is among the lightest 350 horsepower outboards available. This weight advantage allows installation on boats that might struggle supporting heavier alternatives. Pricing sits around $40,000, positioning the BF350 competitively with other 350 horsepower options. Honda's legendary reliability and strong dealer network add value beyond the initial purchase price. If you found this deep dive helpful and want more unfiltered truth about marine engines, check out our video on the submersible engines that power the US Navy. They're pretty special. We've covered insane outboard technology today, from the Mercury V12 Verado 600 to revolutionary 7 marine engines that forced every manufacturer to up their game. The modern high-horsepower market offers unprecedented choices for serious money. V12 sophistication, Yamaha XTO offshore capability, Honda BF350 efficiency, or Mercury racing brutality. But these engines represent massive financial commitments beyond purchase prices. Fuel costs, maintenance, insurance, and repowering create ongoing expenses equaling initial investments. We're living in the golden age of outboard performance, engineering combining sophisticated electronics, advanced materials, and decades of development experience.